Hello again, Math 10Cs. In today's lesson, we are going to continue to talk about functions, which we defined yesterday, where we can actually look at it from two different ways. We can look at a definition of what a function is, where actually it defines it in the notes here. It says a function from a set D, the domain, to a set R, the range, is a relation in which each element of D is related to, is the key part, exactly one element of R, which means that if you were to graph the relation, and I'll just draw a quick sketch of like a relation that would fall into the category of a function. So we have like this curve. And if we were to draw a vertical line anywhere through the graph, the vertical line would only ever touch the graph at one position. If the vertical line only touches the graph at one position, what that means is that for every distinct value of x, there's only going to be one y coordinate that's attached to it. And that's what ultimately defines what a function is going to be. We start to look at the notation a little bit towards the end of the last lesson. So the notation we looked at was when we had the f, and then we had like x arrow y. And again, just to kind of remind you as to what that means, it means f is an abbreviation for function, which again is a special type of relation where for each distinct x value, there's only one y value. And a function is where each distinct x value relates. So the relates is like the arrow that you have here. Each distinct x value relates to exactly one y value. Now let's go through some definitions. So it says consider the function f of the function x, which maps to 2x plus 3. So what that means right here is, again, this 2x plus 3 would be what y is. So if you actually want to write an equation for the relation, the equation would be y is equal to 2x plus 3. So it says under this function, we know that if x is 5, then y would be 13. So we could actually very quickly confirm that. So if x is 5, what I would do is I'd plug it in right here. And then I have y is equal to 2 times 5 plus 3. 2 times 5 is 10, plus 3 would be 13. If you want to, you could write that as an ordered pair, which states that when under this relation, when x is 5, y is 13. Okay, and if you want to write it down in terms of like the arrow mapping, you could simply write down when x is 5, the arrow points to y is 13. When x is 5, y is 13. Now, there's a different name for like the y value that you calculate. So I've actually been using the word value. So when you plug in x equals 5 and you get y equals 13, that's referred to as the value of the function. Specifically, it's the value of the function when x is equal to 5. We can also refer to it as the image. So the image of 5 under this function is 13. Okay, so image is just another word for like what the value of the function is. Okay, so the value of the function when x equals 5 is 13. The image of the function when x equals 5 would be equal to 13. So just two different ways of saying the same thing. Okay, now we're going to get into some slightly different notation. So we'll look at the XY notation. We'll look at the mapping notation. Now we're going to introduce something else called function notation, which is actually a very common type of notation that you'll need to use in math courses moving forward. In most math courses, function notation is used to replace mapping notation. So again, we don't really like to write it like this, okay? Under a function, the image of an element x in the domain is denoted by f bracket x bracket. Now, the way we read that is f of x. And really what this means is like what is f of x? Okay, it means the value of the function at a specific x value. So f bracket x, we read it as f of x. And what that means is it's the value of the function when x is some specific number. Okay, in the example above, the function can be defined by the formula f of x is equal to 2x plus 3. So what I showed up here is I showed that the equation that relates x and y together is 2x plus 3. So I want to just draw the comparison immediately. So we wrote down y is 2x plus 3, but in function notation, so f of x, this means what's the value of the function at a specific x value? Well, that's actually the value of y. So it turns out we can actually use these two interchangeably. The value of the y you calculate is the same thing of f of x, which is the function evaluated at x, because that's what you're doing here. Like when you're plugging in a value of x and you're determining what a value of y is. Okay, but these two mean the same thing. Y and f of x are identical. So let's just go to just draw a quick comparison down here. So let's look at the equation of the graph. So we have this equation, y is equal to 2x plus 3. Now, if we go to function notation, what's f of x? F of x is the value of the function at a specific x value. That's the value of y. So just note here that y and f of x are the same thing. Or we can write in the mapping notation, which says, okay, if we've got a function and you plug in a specific value of x, your output would be determined by 2x plus 3. If we do evaluate this at x equals 5, so we already did this up at the top. So when x is 5, we plug it into the equation. So 2 times 5 plus 3. So in mapping notation, the value of the function when x is equal to 5 would be equal to 13. So when x is 5, the value of y is 13. Okay, we can draw the comparison over here. So if you plug in x equals 5, the value of y when x is 5 is 13. In the function notation, so here's what we start to do now. So you'll notice here that we start off with f of x is 2x plus 3. Now, what we're saying here is we're replacing x with 5. So what this wants me to do is it wants me to determine the value of the function when x is specifically equal to 5. So note what I'm doing here is I'm now replacing. So if I want the value of the function when x is 5, just replace x with 5 and then calculate it. So now what this means is it means the value of the function when x is 5 is equal to 13. And the value of the function when x is 5 is y. Okay, so that f of x, f of 5, that ends up giving you the value of what y is going to be. Okay, and that gives you the value of the function, or we can use that word image as well, the image of the function at a specific x value. So just a couple of notes here. It says f of x does not mean f times x. I know sometimes we use, like when we substitute numbers in brackets, it means you're multiplying the two together. No, this is just notation. It's telling you like what this means. So again, This means the value of the function at a specific value of x. And the name of the function is just f. Okay, so we're just abbreviating a function with f. Okay, let's do some examples now where we play around with this function notation. So it says consider the following two functions. You have f of x is x squared plus 5, and you have g of x is 4 minus x. Okay, so evaluate f of 3. So what this wants me to do is it wants me to take this part of the equation and it wants me to replace x with 3. So if I write that out, it would be f of 3. So that's telling me evaluate the equation when x equals 3. This would be equal to, well, plug in 3 for x. You'd have 3 squared plus 5. 3 squared is 9 plus 5. Therefore, we can write down f of 3 would be equal to 14. And what this means is the value of the function when x is equal to 3 would be 14. Okay, 14 is the value of your output value y. Okay, g of 1. So we're going to use this equation now. So g of 1 means the value of the function when x is equal to 1. So this would be equal to 4. Subtract. This time around, replace x with 1. So if we evaluate that, that would be g of 1 is 4 minus 1 would be 3. The function g. So yeah, usually we use f for function, but you can actually use like all different letters of the alphabet to identify different functions. So g is just a different type of function, just a distinct function from what f is. So g, when evaluated at x equals 1, would have a value that's 3. F of negative 2. So we go back to this equation now, and we're going to evaluate at x equals negative 2. So we'd write down f of negative 2 is equal to, and I'm going to replace x with negative 2 this time. So we have negative 2 squared plus 5. Negative 2 times negative 2 would be positive 4 plus 5. And then you'd have f of negative 2 would be 4 plus 5 is 9. The function, when evaluated at x equals negative 2, is equal to a y value that would be positive 9. G of negative 2, so we go back to the second function. So we'd have g of negative 2 would be equal to 4. Subtract, we replace x with negative 2. When you subtract a negative, you actually add a positive, so we're going to add positive 2. Therefore, the function g, when evaluated at x equals negative 2, would have a y value that's equal to positive 6. Okay, this one wants me to do two things. So it wants me to figure out what f of 0 is, and then it wants me to figure out g of 0, and then it wants me to subtract the two. Okay, let's do f of 0 first. I'll put these in their own set of brackets to show the two separate functions. Okay, so f of 0 would be, okay, we're going to replace x with 0, so we'd have 0 squared plus 5. And then subtract. G of 0 would be 4 minus 0. Okay, so just to kind of clarify what I'm doing here, this part is f of 0. Okay, the function when it evaluated at x equals 0 would just be 0 squared plus 5. And this right here is g of 0. So g of 0 would be the function g evaluated at x is 0. So that's g of 0. Okay, let's clean this up a little bit. So this would be equal to 0 squared plus 5 would just be 5. Subtract, and then 4 minus 0 would just be 4. Therefore, f of 0 minus g of 0 would be equal to positive 1. Okay, second example says consider the function f defined by f of x is equal to 5x cubed minus 2x, where x can be any real number. So A, determine the value of the function when x equals -3. Okay, so we just take the function, we just replace x with -3. So this would be f of -3 would be equal to 5 times -3 cubed minus 2 times -3. Okay, let's carry out the order of operations. So the first thing you want to do is -3 cubed would be -27. Although, you know what, like, just plug it into your calculator. There's no reason, I mean, yeah, you can break it down step by step, but I would just plug it into your calculator exactly how you see it there, just to make this faster. So this would be f of -3 would be equal to positive 14. The function, when evaluated at x equals -3, would have a y value that's equal to 14. The value of f when x equals 2. So what that wants me to do is it wants me to figure out f of 2. So that means the function when evaluated at x equals 2. So this would be equal to, so this time around we just replace x with positive 2. So it would be 5 times positive 2 cubed minus 2 times positive 2. And then we'd have f of 2 would be equal to, and if we plug that in, we would then get, sorry, I realize this should not be positive 14 here. I was looking at the previous example. Maybe I should have done the order of operations. This should be negative 129. There we go. Just a quick little fix there. Okay, f of 2, if you plug that in, that would be 36. The image of 7 under f. Okay, so that just means f of 7. So again, the image is just another name for the value. So the value of the function when x is equal to 7. So f of 7 would be 5. This time we replace x with 7. So 5 times 7 cubed minus 2 times 7. And if we plug that all in, we'd have f of 7 would be equal to 1,701. The function, when evaluated at x equals 7, has a y value of 1701. Now it says an expression for f of a. So this might seem a bit confusing. So you're like, well, what's the number? Well, this time around, it's not a number. You're actually going to plug in a variable and just kind of try to simplify it. So f of a would be, just replace x with a this time. So it would be 5a cubed minus 2 times a. And that's actually as far as you can go because 5a cubed and 2a are not like terms. Therefore, you cannot combine them. Okay, so you kind of just have to leave it at that. The function, when evaluated at x equals a, would have a y value that's equal to 5a cubed minus 2a. Get an expression for f of 2x. Okay, so this time around, what it wants me to do is it wants me to replace x with 2x. And again, anytime you do a substitution, you must put it in brackets. So the way I'm going to write this is instead of writing down x cubed, I'm going to write down 2x, all in brackets, all cubed. And then I'm going to subtract 2. And then instead of x, we're going to write down 2x. So again, just note what I'm doing here. Instead of x, I'm putting in 2x in brackets, all cubed. Instead of x here, I'm putting in 2x. Now this time I actually will complete the order of operations because you can't plug this into your calculator because we have to deal with the variable. So this would be equal to 5 times. Now, when you deal with this exponent here, this exponent has to go to both the 2 and it has to go to the x as well. So this would be 2 cubed is 8. 2 times 2 times 2 is 8. So you'd have 8x cubed. and then minus, well, negative 2 times 2x would just be 4x. Therefore, if we just simplify the first term here, we'd have f of 2x would be equal to 5 times 8 is 40. So you'd have 40 x cubed minus 40x. Okay, 3 says if p of x, so again, you don't have to use f for the name of the function all the time. You can use whatever letter of the alphabet you want. I mean, usually you see f of x, g of x if you have a second function, but you could have p of x as well. Okay, it says if p of x is 4x squared minus 6x plus 1, determine a simplified expression for x minus 3. Okay, so what I'm going to do is I'm going to take x minus 3 and I'm going to replace this x with x minus 3, this x with x minus 3, and I'm going to do it in brackets. So I'd have p of x minus 3. So again, we're replacing x with x minus 3. So I want to evaluate the function when x is x minus 3. So this would be equal to 4. And again, when you do a substitution, put it in brackets. So it's going to be x minus 3 squared minus 6 times x minus 3. Now, this is a bit more annoying to do because if you look at this part right here, we're actually going to have to do some polynomial multiplication. So we're going to have to FOIL this out because when you have a binomial that's squared, the correct way to write this out would be 4, and you'd have x minus 3, and then you'd have x minus 3. Okay, repeated multiplication of that base. Subtract oh, I forgot the 1 here. Whoops. Yeah, there's this 1 at the end. So let's add that in here. Yeah, 4x minus 3 squared minus 6x minus 3 plus 1. Okay, that's going to be equal to 4x minus 3x minus 3 minus 6x minus 3 plus 1. Okay, so the first thing I'm going to do here is I'm going to FOIL this binomial. So if I do that, I would then have p of x minus 3 would be equal to 4. Okay, first times first would be x squared. Outside, outside, it'd be negative 3x. Inside, inside, it'd be negative 3x. Last times last would be negative 3 times negative 3 is positive 9. Okay, now I'm going to deal this part. So I'm going to use distributive property to do this portion here. So I'm going to take the negative 6 and multiply it by the x and multiply it by the negative 3. So this would be negative 6 times x would be negative 6x. Negative 6 times negative 3 would be positive 18. And then we have that plus 1 at the end. Okay, let's collect some like terms here. So I'm going to collect these two middle like terms, and 18 and 1 are also like terms. They're constant terms that can be collected. So then you'd have p of x minus 3 would be equal to, you'd have 4x squared minus 6x plus 9, and then minus 6x plus 1. Now I need to do distributive property again. So I'm going to take this 4 and I'm going to multiply by every term of this trinomial that we have. So this would then be equal to 4x squared minus 24x plus 36 minus 6x plus 1. Okay, let's collect like terms and we'll have our final expression. So negative 24x and negative 6x would combine to give you negative 30x. And then, oh, why did I say 1 here? It should be, jeez, can't add apparently. 18 plus 1 is 19. 18 plus 1 is not 1. Okay, and then we're going to combine these two like terms. And then I would get the function p, when evaluated at x equals x minus 3, would be 4x squared minus 30x. And then 36 and 19 would give you positive 55. Okay, so that one's a little bit trickier to do because you actually have to do some polynomial multiplication. Just drawing back on knowledge from our previous unit. Fourth example, consider the function 10x minus 3, where x is any real number. Determine the value of x if f of x is 47. Okay, so now we're starting to go the other way around, because what it's telling me here is it's saying f of x is 47, so it wants me to plug in a value for f of x. Okay, we're not plugging in a value for x here. Okay, so here's how this would work. So let's write down the function. So we have f of x is equal to 10x minus 3, but it says f of x is 47. So I'm actually going to replace the left-hand side here with 47. So I'm going to have 47, because f of x is 47, is 10x subtract 3. Now, to get the value of x, I just have to solve this linear equation. So to do that, to get x by itself, I'm going to add 3 to both sides of the equation. Add 3. And then I would have 50 is equal to 10x. And then to get x by itself, just divide both sides by 10. Divide 10. Divide 10. And then this would leave me with x is equal to 5. So it's just the opposite thing we're subbing in. Instead of subbing in a value of x, we're replacing f of x, okay? Just remember, too, that like f of x is the same thing as y. So really what we have here is you have like an equation that's y is equal to 10x minus 3. And what it's telling you to do is it's telling you to sub in y equals 47 and then solve for x. Okay, so solve the equation when f of x is negative 23. So same thing. We're going to start off by writing down the function. So f of x is equal to 10x minus 23. And we're going to replace f of x with negative 23. So again, the key thing here is that f of x is the same thing as negative 23. So in this equation up here, I'm just going to replace y with negative 23 because y is f of x. So then this would look like negative 23 is equal to 10x oops, I wrote that down wrong. Sorry. The equation is f of x is 10x minus 3. Okay. And now we want to solve for x. So same thing. Let's get it x isolated by starting off by getting rid of that constant term. So we're going to add 3. We're going to add 3. And that's going to give me, that'd be negative 20 is equal to 10x. And then to get x by itself, just divide both sides of the equation by 10. And then I would get x is equal to negative 2. So which means when y is negative 23, x is negative 2. Or in part A, when y is 47, x is 5. So we're just doing the other way around. We're starting at the output value and we're trying to go backwards and figure out what the input value is. Okay, one more example. So we have the function f of x is x squared minus 5, where x can be any real number. Okay, so it says evaluate f of 4. So f of 4 means we're just going to plug in x equals 4. So f of 4, so I'm just going to sub this in for x here, would be equal to 4 squared minus 5. 4 squared is 16, minus 5 would be 11. So you'd have the function when evaluated x equals 4 is 11. Solve the equation when f of x equals 4. Okay, so it's telling you the value of f of x. So it's telling you the value of y. And just remember, f of x and y are the same thing. So this time around, it's giving you the output value, okay, which is y is 4, or f of x is 4. We're going to sub it in here. Okay, so let's write down this. So we'd have f of x is equal to x squared minus 5. And f of x, or y, has a value of 4. So we're going to plug it in so at this location. So 4 is equal to x squared minus 5. Now I want to get x squared isolated. So get rid of that constant term. Add 5. Add 5. And then you'd have 9 is equal to x squared. But I want x, not x squared. So to get rid of the square, you got to take the square root of both sides. So square root of this side, square root of that side. And then x can be either, it can be plus 3 or it can be negative 3. So it can be plus or minus 3, because positive 3 times positive 3 is positive 9. Negative 3 times negative 3 is also positive 9. So we'll box that. C says solve the equation f of t is equal to 75 where t is greater than 0. Answer in the simplest radical form. Okay, so let's see what happens here. Okay, first things first, it says f of t. So what I'm going to do is I'm going to rewrite this equation, except write it in terms of t instead of x. So your equation starts off as f of x is equal to x squared minus 5. Now, f of t means evaluate the equation when x is t. So all I do here is I just replace x squared with t. So the f of t is t squared, subtract 5. Now what I'm going to do is we're going to replace f of t with 75. So it's this side of the equation that's going to get replaced. Okay, that's the value of y. So just remember, it's f of x is just another way of writing down what the output value is. Okay, so this would then be 75 is equal to t squared minus 5. And let's get t squared isolated. So add 5 to both sides. And then you would have 80 is equal to t squared. Now to get t, I'm going to take the square root of both sides. But now here's where you have a problem. So the square root of t squared is t. But the issue with the square root of 80 is that it's not a perfect square. So you can't just write it down as like a nice number like you did in part B, because you got a perfect, 9 is a perfect square. Now, you could plug that into your calculator and you can get like an irrational number, but we don't want that. It says you must simplify in simplest radical form. So what it wants me to do here is it wants me to turn it into a mixed radical. So we want to take the entire radical, which is like square root of c, and I want to write in the form square root of a, or a times the square root of b. So this goes back to the first unit in the course. So the way to do this is you want to write this down as the product of two radicals where one of those radicals must be a perfect square. Okay, and specifically you want it to be the highest perfect square possible. So if you do this correctly, okay, so I want to write this down as the product of two numbers where one of the numbers is the highest perfect square you can get. So that's actually going to be 16 times 5. Now, if you have two numbers multiplied together under a radical, we can actually write that as the root of each of them multiplied together. So this would be square root of 16 times square root of 5. And then the square root of 16 can be positive or negative 4. However, it tells me right here the value of t has to be greater than 0. Therefore, we're just going to take the principal square root, which is positive 4. And then it would be t is 4 square root 5. It's again a bit tougher because again you have to draw knowledge from the first unit of study in the course. All right, that's it for this lesson. And you can practice by completing starting on page 468. Do numbers 6 through 11 and do all parts of those questions. And I'll talk to you in the next lesson.